Hey, this is a help video for 2.3 explicit formulas for geometric sequences. Let's take a look at this first one. Now, if you didn't know, you might look at this and say, is it adding or multiplying? Well, I think this is multiplying. It's getting big really fast, but we can check. One way that we can check is to take any one term and divide by the term to the left. Take this term and divide by the term to the left. Take this term and divide by the term to the left. And what you'll notice is that if we take a term and divide by the one to the left, we get the same answer every time. That's called the common ratio. So the common ratio in this case is the R, call that the common ratio, is -5. Now, just a little quick tip here. Why a -5? Notice how this one is going from positive and positive, but every other term is a negative. That's happening because of this negative right here. That's what's making it go positive, negative, positive, negative. That's a just dead giveaway. Anytime you see a positive, negative pattern, that you're multiplying by a negative number. So let's do a couple things. Let's find both the recursive and the explicit formula. I think that would be good. Adjust my camera there. So the recursive formula would be to say a sub n is equal to, what are we multiplying by every time? We're multiplying by -5. And we're multiplying that by the previous term. So that's all this says. This says take the previous term and multiply by 5. Now, let's do the explicit formula. The explicit formula would let us find any particular term. So a sub n is equal to, now here we need the first term. The first term is 4. This is a sub 1, right? I'm trying to use colors to help you see. So this is a sub 1. So you need the first term. You need to multiply it by your common ratio. So your first term times r to the power of, so this is an exponent, n minus 1. So just so that we're clear, let me separate these with a line here. So that's that one, and that's this one. So let's come up here and write the general formulas. So recursive says a sub n is equal to your common ratio times a sub n minus 1. Okay? It just says, what are you multiplying by every time? That's all it says. And your explicit ratio is a sub n is equal to your starting point, which is a sub 1, and multiply that by your common ratio, and that is all to the power of n minus 1. You might say, well, why is it an exponent? It's an exponent because an exponent means multiply over and over and over. That's what an exponent means, repeated multiplication. And because our pattern is multiplication, the exponent says multiply a bunch of times. All right, let's try some more practice ones. Let's go to number 2. So first, we need the common ratio. So the ratio here is a -5. How did I get that? 4 times 5 is 20. 20 times 5 is 100. 100 times 5 is 500. And I know it's negative, again, because of these positive, negative alternating pattern. Every other one is positive, every other one is negative. And that tells me that we're multiplying by a negative number. Now, the recursive formula says a sub n is equal to, what are we multiplying by? Times a sub n minus 1, which is just the previous term. Now, the explicit formula is we need to take the first term, which is negative 4, and we're going to multiply it by negative 5, right? Isn't that what we did? We took this first term and we multiplied it by negative 5 to get here. Sure. And we multiplied it by negative 5 again and multiplied it by negative 5 again. So we're going to multiply it by 5. And the question is, how many times do we multiply it by 5? Well, n minus 1 times. So if we wanted the 8th term, we would multiply by 5 7 times. If we wanted the 20th term, we'd multiply by 5 19 times. And that's what that exponent does for us. It tells us how many times to multiply by negative 5. Let's do a couple more. Let's look at 3. So here, common difference, or sorry, not common difference, common ratio. The common ratio is 4. Now, some people would put a negative 4, but it's not negative 4. If it was a negative 4, this would go negative, positive, and it's not doing that. It's just staying negative. So this is, you can check it. Here, you don't have to trust me. Let's check it. So if we have negative 4 times 4 and times 4 times 4 times 4, see, that stays negative when you multiply by a positive number. What if I had started and multiplied by a negative number? When you multiply by a negative number, you can see it's changing negative, positive, negative, positive. So that's not right. That's not matching what we see here. So that's incorrect. So our ratio is 4. So the recursive formula a sub n is equal to our 4 times a sub n minus 1. And the explicit formula is a sub n times your first, or a sub n equals, your first term, and then you're going to multiply that by 4, but you need to know how many times are you going to multiply that by 4. You're going to multiply that by 4 n minus 1 times. And in the computer, you're going to put parentheses around that to make that all work. There you go. Okay, let's do one more. Let's do number 4. Oh, is there one that gets smaller? Let me look for one that gets smaller. Oh, maybe we should do number 8. Number 8's kind of tricky. There we go. So what is going on with 8? We have a 5, then a 5 halves, then a 5 quarters, then a 5 eighths. So we know what the next one's going to be. It's going to be 5 over 16, and then it's going to be 5 over 32, and 5 over 64. So what's happening is the bottom number is multiplying by 2. The bottom number is multiplying by 2. What does that really mean? That really means that what's happening here, oh, camera moved, there we go. That really means that we're taking 5 and we are dividing by 2. That gives us that, how about this? 5, it'll actually look better if we times by 1/2. You can think of it as dividing by 2, but I think we're better off if we stick with thinking of it as multiplication. So let's think about, what would you multiply to get 5 over 2? You'd multiply by 1/2. Check it out. Then you'd multiply by 1/2 again, and you'd get, oh yeah, there it is. There it is. There it is. So we are multiplying by 1/2. So our common ratio is 1/2. That was kind of tricky. So to write this out, the recursive formula is a sub n is equal to 1/2 times a sub n minus 1. And the explicit formula is a sub n is equal to our first term, which is 5, times our common ratio, and all of that is to the n minus 1 power, because that tells us how many times are we multiplying by 1/2. Well, I hope this helps. Please email me. Let me know how you're doing.